Hello, everybody. So I'm going to be talking today about what I'm calling managing Kubernetes without losing your cool. This is generally going to be kind of my top 10 tips and tricks for how I've managed to work with Kubernetes without kind of pulling all my hair out. Before that, a bit of introduction about me. So as Tom said, I'm a platform engineer here at Giant Swarm. If you want to find me around the internet, you can find me generally as Average Marcus on most places, except for on Twitter, where I'm Marcus_Noble and then an underscore at the end, annoyingly. The reason that I'm talking about this today is I've currently got about 5+ years of running Kubernetes in production. In that time, I've gone from working as an app developer, deploying my applications onto Kubernetes, to building out Kubernetes for other people, to managing Kubernetes for massive amounts of people, and kind of everything in between. So I've dabbled with a bit of kind of like all the different users of Kubernetes, and throughout that time, I've kind of picked up what I'm hoping are some useful tips. So the way we're going to do it, I'm going to break it down into 10 tips. The first 5 should be usable by anybody starting today. A lot of these you're probably already doing, but I'm going to kind of ease into it. And then as we get further on, 6 to 7, we're going to need maybe a little bit of old school ops kind of knowledge. And then 8 to 10 is where it's really good to have a bit of programming knowledge to work on these. So without further ado. Okay, this one's a little bit tongue-in-cheek because this is what Giant Swarm offers, but it is worth mentioning. So if within your organization you have like a dozen different teams, 100 different teams, whatever, and they're all having to also deal with Kubernetes, that's less time that they're spending actually building the stuff that makes you money. So it is also worth considering this as an option. But this isn't why you've come here, so let's move on to the actual interesting stuff. So my first kind of big tip is learn to love your terminal. So whether you use Bash, Fish, ZSH, PowerShell, whatever it be, it's worth spending just a bit of time getting comfortable with what it offers, what the kind of functionalities of it are. It's also worth learning about these RC files. So in Bash, it's a .bash RC file that you'll find in your home directory. These allow you to create some configuration, some aliases, things like that for you to use within your Bash session or your ZSH session, whatever. One of the things that I use quite heavily is alias. This allows you to effectively create your own terminal commands out of more complex commands. It allows you to call other things using an alias. You'll see examples of this as we go through as well. If you're not sure where to start, it's good to look out for what are called dot files on GitHub. I've linked mine here. I'll share all these resources out later, but these are generally collections of configuration and kind of tooling that people have shared for others to then make use of. So if you're doing any sort of interaction with Kubernetes clusters, a lot of your time is generally going to be spent in the terminal. It's good to get familiar with it. Next, following on from that, learn to love the kubecontrol command. So kubecontrol has a lot of functionality built into it. My first tip, going back to tip number 1, let's alias that kubecontrol to something nice and short like K, so that we can kind of stop any like fat fingering when you're typing. You can speed up, K get nodes, that kind of thing. As you can see here, K get pods -A will get you all pods in all namespaces. The official Kubernetes documentation does provide a single page kind of overview of all the Kubernetes commands, all their arguments and things like that. It's really good reference if you're not sure of a particular command or what a particular command can support. It's good to kind of see that and like just Control F, find in page sort of thing. Another really nice feature with kubecontrol is it has this kubecontrol explain command. Now this allows you to get information about various different Kubernetes resources, and it does this by querying the actual API of that resource to get back the details. So for example, here on the right, I'm doing kubecontrol explain pods.spec.containers. So what I'm doing there is I'm saying I want to know what the spec.containers property on pods is. Give me all the information. And you see here, it gives you a bit of a description, the kind of type that it is, and then all the fields that can go in there. This actually scrolls down for quite a lot of pages. And you can do this for any resource within your Kubernetes cluster. Very useful if you're like in an air-gapped kind of environment where you can't go out to the commands page, or you know exactly what it is you're looking for, but you just need a kind of quick and handy reference. Okay, number 3, multiple kube configs. So if you are working with many Kubernetes clusters, like we do here at Giant Swarm, we have hundreds that we have to interact with. It's good to kind of have some process in place to be able to easily switch between different clusters without accidentally taking down production when you were meant to do it to dev, that kind of thing. So for this, I can recommend 3 different tools that you can use. They all effectively do the same thing, but they're just kind of slightly different. What they'll allow you to do is switch from one Kubernetes cluster to another, and also switch between the namespace that you're currently working with. So by default, the default namespace is the one that always gets selected. If you are predominantly working in like a namespace named after your team, you can do kubeNS team name, and then every kind of command from then on will be against that namespace. Now, this image on the right is meant to be a GIF that shows you it in action. Realize now that that's not happening. So use your imagination. In that, it is me typing out kube context and then the name of a cluster, and it kind of switches that cluster and gives me that information. The one I use, if you're interested, is the one at the bottom called kubeswitch. But as I said, they're all pretty much the same. My preference for kubeswitch is it allows you to point at a directory full of manifest files. So you can have each of your cluster manifests handled individually, and it kind of searches over all of them. It's quite nice. Next, so K9S. This was in the one of the poll answers. Now, I spend a lot of my time in this tool. Now, unfortunately, this was also meant to be a GIF, and I realized that's not going to work. Imagine this as being interactive. You can filter, you can search, you can select, you can edit, you can get, all this kind of thing. What K9S is it's a terminal-based GUI for your cluster. It allows you to do everything that you could do with kubecontrol commands, but it exposes it to you in a more graphical way so you can get a nice, good overview. Here on the image, you can see that we're looking at the pods, and you can see all the different pods names down the left. You can see the status of them, the number of restarts, what memory and stuff they're using, all that kind of thing. And from there, you can kind of dig into, okay, let me look at the logs for this pod. Let me edit this deployment to change the number of replicas. Let me set up a port forward to this service so I can test it locally. Things like that. It's a fantastic tool. Number 5, kubecontrol plugins. So I went a good number of years without actually knowing that these were even a thing. So kubecontrol itself can be extended by the use of plugins. And a plugin is anything within your session path that is prefixed with kubecontrol hyphen and then something else. This means that it can be any language that the command's built in. Could be just a bash script. As you can see on the right here, I've got a kubecontrol-hello file that just echoes out hello kube. I can do then kubecontrol space hello, and it'll run that script. Now, that could be done in Go, that could be done in Python, whatever is your language of choice. As long as it's within that, as long as it's within your path and it's got that kubecontrol prefix, it will be picked up. There is, though, a package manager of plugins that people have created. So CRU is a plugin that you can get for kubecontrol that manages plugins for kubecontrol. Bit of inception going on, but it's quite nice. It allows you to just do, as you can see here, kubecontrol CRU install and then the name of the plugin. Now you can go to their page and they've got hundreds of different plugins. Some aren't useful for everybody. Some are quite specific to, say, like dealing with AWS clusters or dealing with something kind of bespoke. Some of the ones that I use quite regularly, Stern is a really good plugin. It allows you to tail logs over multiple pods with filtering and things like that. So it allows you to kind of give it a regular expression for the pod name to match on. So it doesn't even have to be pods within the same deployment. It can be, all pods that are prefixed with a team name, for example. It allows you to tail them, filter them, etc. It's really nice. Tree is also a nice one. It allows you to see the owner references of a resource. So, for example, it will show you that a pod belongs to a replica set, belongs to a deployment. And it can do that with any resources that make use of the owner references property. Outdated is a nice little CLI tool. It'll check the pods that you've got running in your cluster and let you know if any of the images that you've got there are outdated. So if you're providing you're not using like latest or kind of named tags, it should be able to work out whether there's a new version available for you to pull down. And the final one is GS. This is Giant Swarm's own plugin. So we use this internally. We also have it available for our customers. And it just kind of makes it nicer to work with Giant Swarm clusters. So it gives you kind of some helpers. It gives you a better output of, say, kubecontrol, GS, get clusters, for example. And that's a good example of one of these kind of bespoke plugins that may not necessarily work for everybody. So I do recommend having a look on the website, look through the plugins and just kind of try a few of them out. And if you want to write your own, go for it. Cool. So we've rattled through that really quickly. So as I said, number 1 to 5, pretty straightforward, something that generally anybody can get started with as of today. I'm imagining that for a bunch of those, people may have already
Hi, everybody. Marcus just pinged me on Slack and let me know he lost connection. So he may be back with us in just a minute. Sorry about that technical difficulty. Did you hear him when he was leaving? He went, oh. So he will find him in just a minute. He's a pretty quick guy with technology. So he will be back with us momentarily. I'd like to go over these slides with you, but being a marketing person, I could say, for example, good to know a little old school ops first. That's what we'll be getting to next. Marcus, you're getting there. We can hear you.
Yes. Okay. Sorry about that. It kicked me out.
Marcus, I did the rest of it. It's all good. Most people.
All right. Okay.
Welcome back. I'm going to head on out again.
Right. Thank you, Tommy.
Yeah.
Right. Sorry about that, everybody. It was nice that it kind of did that at a nice break junction, but okay, let's carry on. So as I said, 1 to 5 should be able to get started with straight away. I imagine some of you are already using some of these tools. So let's get into something a bit more involved, something that could do with having a little bit of experience of operating of machines and stuff like that, but doesn't necessarily need to. So the first thing I'm going to talk about is KShell and kubecontrol debug. Now, if it loads, really not having a good day. Cool. KShell. So this is going back to tip number 1 again in action. I have an alias in my bash RC files that's called KShell, and what that does, it aliases out to this kubecontrol run command, which allows me to very easily spin up a new pod in a cluster, running the bash image, and then kind of exposes the terminal of that pod to me. This is super useful when I'm trying to work out if a cluster's having networking issues or if it's related to a specific app. So I can bring up this pod within the cluster, and I can do things like doing an NS lookup. Is DNS working? If I get a response, I know that core DNS is okay, and I can rule that out as a potential problem. I can then start doing, I don't know, curling out to an external service or curling one of my internal services to see if there's any network policies in place or if there's any security groups playing or something like that. So this kind of approach is really good for general cluster-wide debugging. Now, if you want to debug an existing pod. So you've got an application that you've deployed onto Kubernetes. It's going a bit weird. You're not quite sure what's going on. That's where kubecontrol exec comes into it. Now, what exec does is pretty similar to what we've just seen, but it gives you the shell environment of that running pod. So you drop straight into it. Here I'm dropping into the SH shell, but it will very much depend on the pod that you're working with. For exec to work, the container that you're trying to get into needs to have some sort of shell environment for you to work with. For example, if you are running a container that's from scratch and then kind of just adding in, say, a built Go binary, there's no shell environment in there, kubecontrol exec won't work for you in that case. We'll come on to a bit more later and how we deal with that. You're also then limited to what's already available within the container. So if it's a full kind of container that's, say, built from Ubuntu as a base, you're going to have quite a lot of tools. If it's not, you may need to see if you can pull some tools down or kind of get them into your pod from the internet somehow. And finally, one of the things that's really going to kind of catch you out a lot of the times is, for this to work, the container actually has to be running. So if your application is crash looping, for example, every time that crashes, you're going to get kicked out of that container. So this is really only useful for situations where, like, your application has been misconfigured. So your application is running, but maybe it's behaving not as you expect, and you want to just make sure that the environment that it sees is what you expect. That sort of thing. So, as I said, if your container doesn't have a shell, you will see something like at the top here. So, internal error occurred, error, executing command, blah, 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 blah. Now, we can still do some kind of debugging here. So, since Kubernetes 1.23 and the associated kubecontrol release, there is now a kubecontrol debug command. Now, what this does is it effectively lets you inject a new container into your pod alongside the existing ones. So you don't get quite the same level of access you do with kubecontrol exec, but you can kind of see some more specific debugging to that application. It would mean that things like shared volumes within your pod, you could be able to mount those and access those. You could do some network checks to see if network policies are restricting your specific application, things like that. And you can use it to investigate a crash looping pod. So because you're injecting a new container into this pod that's not crashing, you can still have an environment running while your pod's crash looping. The amount of information you might be able to get from that will depend on the pod itself and whether there's shared volumes or anything along those sort of lines, but it at least lets you get a little bit closer to the actual issue to start debugging. Now, each of these are kind of useful in different scenarios. So, as I said, that KShell alias that I use, that's generally for when I'm seeing issues with multiple workloads within a cluster. So, generally, this is networking. I want to see if core DNS is broken. I want to see if my network CNI is broken, that kind of thing. If I've got a workload that is running but is acting a bit weird, I'll generally go for kubecontrol exec. If my container has enough for me to actually get a shell. If the workload is not running as expected, but it's not crash looping, but it doesn't have that, that's where I'd start using the kubecontrol debug. Similarly, if it was crash looping, kubecontrol debug. Now, next command. This is another of my shell aliases. So there's two that I kind of can recommend. So I built my own little script several years ago now called kubessh. After starting Giant Swarm, I found out that they had a very similar one called kubeenter. What this does is it allows you to have an SSH-like access to the underlying host of a node. Now, it's not true SSH, so you don't get things like key exchange, port forward, things like that. What it does do is it will launch a pod in your cluster that has privileged permissions and drops you into the node underneath as a process on the host nodes. You can then interact with it. Now, the example here, I'm curling this shell script and it's then running it. Please don't do that. Please do it. Please check any shell scripts that you are running from the internet so that you trust them. I'm including it here just for as an example. So what this will do, it first checks all of the nodes within your cluster, lists them out and gets the node names of them all and asks which one you want to drop into. When you select one of those, you'll then be presented with a shell, as you see here, which you are then on the host node. The reason that I like this approach is I will generally prefer underlying hosts that have kind of the limited attack surface. So I don't want to expose SSH. I want them to be ephemeral. I want them to be ones that I can kind of throw away and get replaced without any issue. Having SSH on there can sometimes lead to people going on doing some hot fixes to fix something in production that then gets forgotten about, and when the node gets replaced, it's broken again, things like that. But there are situations where you do necessarily need to get onto a node. You want to see, say, the system log of that node and see what's going wrong. So there are situations where I like to use it. So how this works, it's very similar to the KShell command that I showed you. It again does a kubecontrol run, but with a lot more stuff in it, basically. We'll set a node selector so that we get onto the node that we're expecting. We'll set a toleration for everything so that we can also run on the control plane nodes. And then we'll set the image that we want to use, set it to privileged, host PID, host network, all that kind of thing. So we're then running as close to the host machine as possible. What that's then running is this Docker file on the right. All this Docker file is pretty much building this ns-enter command. We're then using that to piggyback onto the node underneath. There are some caveats with this approach, though. Similarly to with kubecontrol exec, the underlying host needs to have a shell that you can get access to. So for example, if any of you use Talos for your Kubernetes clusters, like I do at home, this won't work. Talos has no shell. It's all API driven, so this will not work. You also need enough RBAC-based permissions to be able to launch a privileged pod in this sort of way. So things that could prevent this are things like your RBAC, your PSPs, admission controllers, various things. This could also be seen as a benefit in that you can use your same Kubernetes authentication restrictions to also restrict the access to the node itself. Whereas with SSH, you kind of have to deal with that again separately, and there's pros and cons. It's not, as I said, it's not a real SSH session. So there's no key authentication, file transfer, port forwarding, all that kind of thing. You've got none of that. It is just a shell. And just for completeness, ns-enter from the man page, ns-enter command executes a program in the namespace that are then specified in the command line options. So all that means is we're just basically executing a command in the namespace, here being process namespace, not Kubernetes namespace. So we'll piggyback onto the underlying node. Cool. So 7 down. Pretty good so far. Now we're going to get into things where it takes potentially a little bit more programming. Not all of these will necessarily need you to be an expert programmer, but to make full-fledged use of them, it definitely does help. So let's crack on. Number 8, webhooks. So I have a love-hate relationship with webhooks. They're both extremely useful and extremely frustrating, and you'll see why as I kind of go through this. So there's 2 types of webhooks. For this example, we're going to ignore the CRD conversion webhooks as they're separate. There's validating webhooks and there's mutating webhooks. So validating webhooks basically allow you to say, can a particular request be performed, yes or no? And then a mutating webhook can actually modify the requests that are being made to an API server. So whether that is adding fields, removing fields, defaulting fields, stuff like that. Now, one of the things that is quite nice with webhooks is you can implement some more advanced access control than is possible in RBAC. I'll come to this in detail in a little bit later because we've actually had to implement this at Giant Swarm for a particular issue. But the mutated webhooks, for example, is really good for doing things like adding default labels. So if you've got policies within your organization where every pod has to be labeled with the team that owns that pod, you could potentially have a webhook that, okay, if a pod's being deployed into namespace team 1, give it the label team 1, things like that. It also allows you to enforce certain policies as well. So, for example, if you want to prevent any containers being launched within your cluster using the latest tag, image tag, that can be blocked by a webhook. And will also things like if you want to have default resource limits, you can block deployments that haven't got those specified, for example. The last one, which I quite like, is the hotfix for Log4j. I saw your question, Marco. I'll share out the links to these later so you can actually see this. But what this does is it injects an environment variable into all pods that are created that sets this log4j format message, no lookups, environment variable. I can't remember what the value is off the top of my head, but it sets it to something that then prevents the log4j exploit being exploitable. So it kind of turns off whatever feature it is that it exploits under the hood. Cool. So we've got an example here on the right of a policy that a Kubernetes policy that we've used. So with webhooks, generally speaking, there's 3 kind of popular ways of making use of them. You could build your own operator and implement custom logic yourself and kind of all the DIY kind of approach to it. Or there's 2 open source projects that are quite popular. So Kubernetes, we use this quite heavily within Giant Swarm. Kubernetes is a Kubernetes native policy management, so it gives you custom resource definitions for policy and cluster policies that you can then apply using YAML, as you can see here on the right. Or there's OPA Gatekeeper that is built on top of Open Policy Agent and allows you to then use that. I personally don't have much experience with that, so I'm not going to talk too much about that, but they're roughly the same sort of thing. So going to this Kubernetes policy, as I said previously, using webhooks allow you to have some more advanced access control. One issue that we had at Giant Swarm was there was a bug in our cubecontrol GS plugin, which was mistakenly deleting all certificates when we were trying to delete one certificate. Now, we couldn't block this with RBAC because we still needed the one certificate to be allowed to be deleted. Now, we can't take away permissions using RBAC, so if you were a cluster admin, you could do whatever you want, and this bug then wreaked havoc. What this Kubernetes policy allowed us to do is block any bulk deletes of this cert config resource type. As you can see here, underneath the resource kind, you've got cert config. And basically, if the operation is a delete and there's no specific name given, which then means it's basically a delete/all, it will block that and prevent it from happening while still allowing the valid operations to happen. This then allowed us to block that bug, give a message to our users, say, please update your kubecontrol version, and then we're all good once everybody's done it. Some notes for webhooks. So where possible, avoid applying webhook resources in kube system namespace. There are situations where this can cause a deadlock, and this is one of the things that we see quite a lot in the clusters that we manage for when a cluster is down. So, for example, if you have a Kubernetes webhook, for example, that you've specified to run on every pod creation, if your control plane node goes down, when it comes back up, you're going to have a problem that it needs to run the webhook to create the pods for the API server, but there's nothing to call it, and you're basically in a state where your cluster's down and it can't come back up until you remove that webhook. So be very careful as to what you're targeting with your webhooks. Where possible, use object selectors, namespace selectors, things like that, so that you kind of limit the blast radius of these. Be aware of the failure policy property on it. It defaults to fail, which again can cause trouble. If your webhook service goes down, if the code behind it goes down, all of those webhooks are then going to fail as well and get blocked. You can set that to allow, I think, is the other option. That if it's unable to access your code behind it, it can still launch whatever it's trying to do. Obviously, this isn't very useful if you're using it for security reasons, but for things like maybe defaulting or something like that, it might be okay in this scenario where it can still go ahead. The reinvocation policy is interesting. So this tells the Kubernetes cluster as to whether we want to rerun a mutating webhook once it has gone through other webhooks. So for example, if I've got a mutating webhook that adds in a new container within a pod, I may have another webhook that I want to then run again if it's already run to maybe do something on that container. Be a bit careful with that, because you don't want kind of every API call to take ages if they are potentially kind of rerunning and things like that. So use that sparingly. Finally, there's no ordering when it comes to webhooks. It first does mutating webhooks, and then it does validating webhooks. But within those two groupings, you can't guarantee the order that those webhooks will be applied in. So don't rely on the output of one webhook don't rely on the output of one webhook for the input of another webhook, because they may not necessarily run in the order that you expect. Cool. So let's get to some more nitty-gritty stuff. So the Kubernetes API. All Kubernetes operations are done via the API. So kubecontrol uses it, any in-cluster controllers use it, scheduler uses it, all these UI tools use it. You can use it too. It's just an API. There is a REST API available and a GraphQL API. I don't really know anything about the GraphQL API, so we're going to ignore that for now and focus solely on the REST API. The API can also be extended. This is either through the creation of custom resource definitions. We've seen a little bit of examples of this already. So, for example, the Kubernetes policy, or by implementing an aggregation layer, such as what the metric server does to expose the metrics. I'm not going to be covering that in this talk today. So, yeah. The easiest way to try out the Kubernetes API directly is via kubecontrol. So kubecontrol has a -- raw argument that you can then give it an endpoint, a path endpoint, to then call it as though you're calling the REST API. The nice thing about this is kubecontrol will handle all the authentication for you based on your kube config, so you can kind of use it to explore the API a bit and try things out before you then build it into your own applications. Now, there are 4 kubecontrol commands that map to these 4 HTTP methods. So there's kubecontrol get for a get, create for a post, delete for a delete, and replace for a put command. Now, as you can see in this example here, this is equivalent of us doing kubecontrol get pods dash namespace default. And that's what that will give us there. We'll break this down a little bit more. To know what APIs there are available, there is also a kubecontrol command to give you that. So if you do kubecontrol API resources, it will give you a big list of all of the resources and their APIs that are available within your given cluster. The format of the endpoint varies slightly. So it starts off with the API version. I'll explain this a little bit in a second, followed by namespace / the namespace if you are looking for a namespaced property. If it's cluster scoped, we will omit that completely, or if you want to search all namespace, again, we'll omit that completely. Finally, the resource kind, and then / the actual resource name itself if you're looking for a single resource. Again, omit that if you want to search for all of those resource kinds. So the API version at the beginning. The API version column quite nicely says this. If the API version just says v1, this is the core API and will be available on /API/v1/ whatever the resource is. Now, if it doesn't say just v1, it gets a little bit different. It's /APIs with an S on the end / the version that you see in the in this column. So, for example, for deployments, it'd be under /APIs/apps/v1/ deployment. So be wary about that extra S in this case if you're working with any of the non-core APIs. So you also can then see whether a resource is namespaced or not. So in this instance, it's whether a resource is cluster scoped or whether it's bound to a specific namespace. If namespace column is false, that's cluster scoped, and then you just omit the namespace /name entirely. If it's true and you want to search over all namespaces within your cluster, again, you can omit that. Otherwise, if you want to search a specific namespace, it's namespace / that name. If you want to search over, say, 3 namespaces, you need to do 3 commands to do that. Some resources you can use to make this much easier. There are lots of libraries available for this. The official Golang library is available at Kubernetes/Go, client Go. That's what's used by a lot of the Kubernetes operators. That's what's used by kubecontrol under the hood, things like that. One thing I forgot to mention, the commands that kubecontrol runs don't necessarily map to a single API call. A lot of the time under the hood, this client is actually doing several API calls for a particular action. To just makes it easier for the user using kubecontrol not to have to know every single API interaction. So just be aware of that there may not necessarily be an exact mapping from kubecontrol commands to an API endpoint. There's also Terraform provider. If you're all in on Terraform, again, under the hood, that just uses the Go client as well. Then on GitHub, there is a Kubernetes-client organization. Within that org, there are lots of repos for officially supported clients for many, many, many different languages. So there is a good chance that there is one for whatever language you write in. Now, why would we want to use the Kubernetes API? So this is quite useful if we want to kind of build our own tooling that's a bit more complex than maybe just wrapping around kubecontrol. So where maybe those aliases aren't quite as complex as we potentially like, we may want to actually build out a tool. So a good example of this is the K9S application that I showed you earlier. That's then using the API all under the hood to expose it in a new way. Similarly, desktop applications like Lens, things like that is also the same. You may also want to do some quite advanced cluster automation. So as part of the CI jobs, cron jobs, maybe you want to interact directly with the API rather than, say, pulling in kubecontrol and having all the needed necessaries of that. You can just do your direct interactions. And finally, extending Kubernetes itself with your own operators. We'll mention this a little bit shortly. But this is if you want to add some more functionality. Again, kind of the extension that I mentioned earlier, at creating your own CRDs, you may want to do that with your own operator to add some logic, things like that. So on that note, let's talk about CRDs and operators. 1 second. So CRDs and operators. CRD is a custom resource definition. And this allows you to create your own Kubernetes resources on top of the existing resources that Kubernetes ships with. Excuse me. We've seen a lot of examples of this already. Kuverno policies, cluster policies, they are CRDs. You've probably seen things like certificates from the Acme group. That's a CRD. Basically, anything that you want to add on top of Kubernetes, create your own logic, make Kubernetes more powerful. The core kind of beauty of Kubernetes, at least in my opinion, is the API. You can build on this API and kind of make it do almost anything that you want and expose it through CRDs and these operators. So The way it works is you have a CRD that defines your resource, so the fields that it's allowed to have, the status that it can have, things like that, any of the field restrictions, stuff like that. A user comes along and makes a modification to a custom resources, so creating, deleting, updating, any of those things. Within the cluster, we've then got this operator running that is watching those custom resources. Now, it's worth pointing out that operators don't have to run against custom resources. They can run against just your standard Kubernetes resources, like a deployment, like an ingress, whatever it may be. Just for completeness sake, we're going to include CRDs in this. So that operator sees that change, it gets alerted to that change and sees what the change is, and it then checks its logic and says, okay, this change, I need to do this thing. So for example, the Cluster API project, that heavily uses CRDs and operators. You'll create a CRD that is, for example, AWS cluster, giving it all these properties. The operator will see that being created and it will go off to the AWS account and create all of the EC2 instances, the VPC, etc. that's needed for that. It then adjusts the state of that custom resource, so it updates the status or any kind of child resources or anything that's needed for that. And then it goes back to the beginning and checks again. And it keeps doing this. So it runs this reconciliation loop, just like everything else within Kubernetes. So you make changes to a deployment, that also happens. As I said, this can run against your kind of built-in Kubernetes resources. So a really good example of this is the ingress resource. So out of the box, Kubernetes has an ingress resource, but it doesn't have an ingress controller or an operator. These custom ones, so Nginx, for example, traffic, whatever your choice is, will still watch those ingress resources, potentially in addition to their own custom resources, and perform some logic based on that. Now, this is a big topic. And it's not something that I can really cover within this and do it justice. So instead of me kind of making them, not giving you the full details, I would highly recommend some other resources on this topic. So if you are looking to build out your own operators, there's a few frameworks here that are quite popular. KubeBuilder, I think it is probably one of the most popular ones. So that's what things like Cluster API is built in. We're using a lot of that within Giant Swarm as well to build out some of our own operators. But there are others as well that you can use. This is just a nice subset. The Kubernetes documentation also has a quite nice article on operators, what they are, what they kind of can achieve, things like that. And our friends at Container Solutions also have a really good blog post on this, which the image from the previous slide is actually taken from. I highly recommend you checking that out if you are interested in more about how operators work and the CRDs and things like that. There's also Operator Hub, which is a directory of operators that people have built. Majority of those are built using the operator framework. As you can see here, the operator framework. But there are others in there as well. So it's kind of good to kind of see if there's already an existing operator for the thing you want to do, or if just to get some kind of ideas on how to build them, what you can build them with, things like that. There's also some videos that I highly recommend watching. So there's one from my friends at Civo around writing Kubernetes operators from scratch. There's one at a previous KubeCon about writing operators, and final one, Smooth Operator, Rough Guide to Kubernetes Operators. All of those are kind of good videos to give you an understanding of what an operator is and kind of give you the conceptual knowledge to then start building out your own. I'll make sure all of these get shared out after the webinar so that you kind of don't have to note these all down now. So, too far. So that's my 10 tips. So we've kind of gone through them all. First 5, I said, quite easy. I think we could all kind of get on board with those. 6 to 7, I think everybody's going to be pretty comfortable with those. I don't need too much knowledge. And 8 to 10, as I said, if you have a bit of programming experience, experimenting with these features, so the webhook, the CRDs, things like that, just trying them out, seeing what you can do with them. Give it a go. Yeah. So in summary, take some time, learn your terminal, learn your CLI commands, so kubecontrol, kube switch if you want to use that, K9S, things like that. Build out your own repertoire of aliases and bash configuration of things to make your day-to-day easier and less stressful. Then build on top of Kubernetes. So leverage the webhooks, leverage the API, leverage the CRDs and stuff, and make Kubernetes do more than it does out the box, and make it more specific to your needs, your use cases, and things like that. Thank you.